The universe is extremely large, so large that measuring how far away things are is very challenging. So astronomers have had to be creative.
One way uses redshift to measure distance. To understand how distance and redshift are related, let's go back to the beginning.
In the 1920s, Edwin Hubble and other astronomers measured the redshift of galaxies. They discovered that everything was moving away from us, that the universe was expanding. Hubble knew that when galaxies were moving away from us, their light was redshifted. By measuring the amount of redshift, astronomers can work out how fast the galaxy is moving away from us. This is called its recessional velocity. Hubble also discovered that there is a relationship between the recessional velocity of galaxies and their distance from Earth. The further away they are, the faster they appear to be moving away from us, and the more their light is redshifted. This linear relationship is known as Hubble's law. It means that the recessional velocity of a galaxy can be used to estimate how far away it is.
But there's a problem. The light from the most distant galaxies is redshifted so much they would have to be travelling at amazing velocities, near the speed of light. So what's causing the light to become so redshifted?
As light leaves a distant galaxy and travels to us, it journeys through vast regions of expanding space. The expanding space causes the waves to be stretched and their wavelength increased. The light gets redshifted by the expansion of space itself. The further away a galaxy is, the longer it takes the light to get to us, and the more it is stretched or redshifted. Light from nearby galaxies doesn't travel through enough space for us to notice the effect from the expansion, so the redshift we measure is due to the galaxy moving away from us. However, the further away a galaxy is, the more effect expanding space has on its redshift. But how do astronomers use redshift to help answer questions about the universe? Automated robotic telescopes conduct surveys by measuring the redshift of a large number of galaxies. This shows astronomers the large structures of the universe, such as groups of galaxies.
This is a redshift survey of the sky. It shows where there are groups of galaxies and where there are gaps with very few galaxies. Without redshift, we wouldn't have a 3D view of the universe because we wouldn't know that these galaxies are further away from the Earth than these galaxies. Figuring out the structure of the universe is a complex business. As telescopes get bigger and better and therefore collect more light, astronomers are finding and measuring more galaxies and learning more about our place in the universe.